Alright, hi, this is Yvonne Yu and Andrew Manahan from Ms. Bouget's Period 3 Physics Honors class. Today we're going to make a screencast to show energy conversions. In our scenario, Andrew's going to run, jump, and grab the rim of the basketball hoop. The system is Andrew's hand and the earth. We hypothesize an equation using a bar chart, and then we use the equation to show that energy was transformed from kinetic energy to gravitational potential energy. The equation also shows that the amount of energy remains the same, so energy was conserved.
Centimeters?
Whatever.
147 inches. It is 10. Oh, fuck. That's 10, that's 10? 10. Yeah, we're good, we're good.
Oh, that was...
Yeah, DJ, press that.
Alright, so in our screencast, in our little experiment, in this picture, in the initial picture, my hand was a 0 mark, and then in the final picture, the rim was my final position, where my hand was. Where my hand was on the rim was my final position. And then the system we chose was the earth and my hand. Here we have a bar chart explaining the energy conversion. I first start off with kinetic energy, and then it ultimately transfers to gravitational potential because there's an increase in height.
Okay, so after that, we measured the distance from where Andrew started running to the place where he started jumping, which is 147 inches, and then we converted it to meters, so it was 3.73 meters. So velocity is calculated by displacement over time. So we also timed how long it took him to run that distance, which was 0.6 seconds. So we did 3.73 meters divided by 0.6 seconds, and we got a velocity of 6.22 meters per second. So before Andrew jumped into the air, he was going at 6.22 meters per second. After that, we also measured the distance from his hand to the ground right before he jumped, which was 6.5 feet, and then we converted that to meters, so it's 1.98 meters. Using the bar chart, we came up with the equation initial kinetic energy is transformed to final gravitational potential energy. So the 1/2 mv squared equals mgh, and the m's on both sides cancel out because they're the same. So essentially we have 1/2 v squared equals gh. And then we plugged in the values, 6.22 meters per second for the initial velocity and 1.98 meters for the height. And we got 19.34 joules for the kinetic energy and 19.42 joules for the gravitational potential energy. The two values are very similar, so it shows that energy was conserved, so it follows the law of conservation of energy. This happens because energy cannot be created or destroyed, it can only be converted from different forms, so it was converted from kinetic to gravitational potential energy. Possible reasons for the discrepancy in numbers is possible air resistance, which we assumed was 0, or friction, and we also couldn't time we didn't time it exactly for how long it took him to run the distance, so that could be a cause for the slight off of the answer.